Hello students, today's agenda is to check your homework. We're going to be reviewing powers and square roots, and you will be able to work on 8.4. Today's students will be able to simplify some powers by following the laws of exponents and simplify square roots. So, you have seen this before, but just to make sure that you remember them, because we will be using them throughout this unit. That's why we're reviewing the laws of power as well as square roots. So let's start with a to the third times a to the second. A to the third means a times 8 times 8. A to the second means a times 8. So we can say that we're multiplying in here when we're multiplying the same base. How many 8s do I have? 1, 2, 3, 4, 5. So basically is the multiplication of 8 times itself 5 times. If you notice, instead of doing all this work, what we could do is keep the base and add the exponents, because we're just putting together how many 8s we're multiplying. Okay, so in multiplication, if we recall, we keep the base and add the exponents. Okay. Now what if we're dividing? In here we're dividing 0 to the 7th by 0 to the 4th. This means z times z times z times z times z times z times z divided by z times z times z times z 4 times. And in division, we can say that z divided by c is equals to 1, c divided by c is equals to 1, equals to 1, equals to 1, and we end up with 0 to the 3rd power. Okay, so in division, if you notice, instead of doing all this work, what we could do is keep the base only once, because some people get confused and put a z on top and a z on the bottom. No, it's just keep the base and subtract the exponents. 7 minus 4 is 3. Okay, so in division, keep the base and subtract the exponents. Now what about when we have a power raised to another power? Remember that powers or exponents tell me how many times to multiply times itself its base, but in this case the base is a whole power in itself. So it's going to be 5 to the 4th times 5 to the 4th times 5 to the 4th 3 times. 1, 2, 3. And we could apply the same law for number 1, that in multiplication we keep the base and add the exponents. So 4 plus 4 plus 4 is 12. However, again, we can go directly to the answer from here instead of doing all this work. How? We keep the base and multiply the exponents. And that's only when we have an exponent inside and outside of the same parentheses. Okay, so this is called power raised to another power. And what is the law for a power raised to another power? We keep the base and multiply the exponents. Okay? Now sometimes we're going to have something like this. And this is division just like the second one in here, where we keep the base. If it's the same base, we keep the base and subtract the exponents. Remember, these laws apply only if the base is the same. We keep the base and add the exponents. We keep the base and subtract the exponents in division. So in here it's division, so we keep the base, subtract exponents. 2 minus 4 is -2. However, we cannot have a negative exponent. Now, how can we do it then? If we were to do the long work, remember that I like to show how do you do it in the long way. From here, this means 2 times 2, and then in here is 2 times 2 times 2 times 2. We cancel this, and 2 divided by 2 is 1. 2 divided by 2 is 1, so we put that 1 on top, and we have 2 to the second power in the denominator. This answer came from this exercise. This answer came from this exercise. So we can say then that whenever we have the base to the power that is negative, we can send it to the denominator and make the the exponent positive. So if you notice, anytime that you have a negative exponent, all you have to do to make it positive, send it to the denominator to make the exponent positive. If there is nothing else on top, you just replace it with a 1 in the numerator. If there was an x in here, then you would just put the x and no 1. Okay, so let me write that. Negative exponent. So what do we do for negative exponents? Send the power to the denominator. Send the power to the denominator. To make the exponent positive. To make the exponent positive. Okay, and this will be the reason. Basically, sorry. We have two twos over here. We have 4 over here, so we end up with 2 of them in the denominator. Okay, but if we had a negative, just in the problem was just like this, all you had to do is send it to the denominator to make the exponent positive. Okay? Now what if we have to the -8? Same rule, except that in here we don't have to simplify it first into a negative. They are already giving us a negative exponent. All you have to do is put it in the denominator, including the base, but with the exponent now positive. So it's going to be 1 over 2 to the positive 8. Okay, this will be your answer. Okay, 2 to the 6th divided by 2 to the 6th. If we were to follow the division rule, we have the same base, we keep the base and subtract the exponent, right? That's what it says in here. So we have the same base, we keep the base and subtract the exponents. 6 minus 6 is 0. So what happens when we have a base with exponent 0? Okay, the long way it would look like this. 2 to the 6 means 2 times 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2 times 2 times 2. And 2 divided by 2 is 1, times 1, times 1, times 1, times 1, times 1 is equals to 1. So if this answer comes from here, from this exercise, and this answer comes from this exercise, so then we can say that 2 to the 0 is exactly the same as 1. Okay, so we can say that for 0 exponent, the power, meaning this whole thing, the power becomes or is equal to 1. Okay, so the answer of anything raised to the 0 power is 1. For example, if we have x to the 0 equals 1. 3 to the 40 times x to the negative 5 times y to the second power all to the 0 power, that's equals to 1. Just because this whole base is equals to, to the power of 0, the answer will be 1. But if we have 3x to the 0, this 0 belongs to the x only. So it means that it's going to be 3 times x to the 0 equals 1. So 3 times 1 is 3. So be careful. The 0 makes the power 1, but only whatever involves for that one exponent. Okay, the exponent of 0. So 3 times 1 equals 3. Okay. Okay, let's do now some square roots. So, if you don't remember what the square roots mean, I'll explain it to you right now. It means that we're looking for a number that multiplied times itself is equals to that number inside of the square root. And that's only for the square root, okay? So, let me see, how can I write that? What number multiplied by itself and we're going to be working with different indexes here, and you might not know what that means right now, but you'll see in a few minutes. Let's say that if I have a 4 as the index, this many times. For example, if we have the root, but the index is 4, then that means that we're looking for a number that multiplies 4 times, and it will be equals to the number inside. Okay, So what number multiplied by itself this many times equals the number inside of the root. So the number that is right there, basically. In this case, 36. Now, if there is no number, like in the first case, that means that the index is at 2. Okay? So what number multiplied times itself 2 times equals 36? Well, that will be 6, because 6 times 6 equals 36. So this is going to be my answer. What about the cubic root of 125? So one number multiplied times itself 3 times equals 125. So for some of you, you know that 5 times 5 times 5 is 125, so it will be, the answer will be 5. If you don't remember, then you would have to do the factor tree, so prime factorization, and we would say that 5 goes into 125, 25 times, because 5 times 25 is 125. Then 5 times 5 is 25, and so we need to group 3 of them, and so the answer will be 5. Okay, we group 3 of them. Okay, what about remember, if there is no index, that means that there is a 2 in there. So one number multiplied times itself 2 times equals 144. Even though I know the answer already, I'm going to do prime factorization so that if you don't remember how to do this, you can practice. So how many times does the 2 go into 144? Well, that will be 72 times. 2 times 36 would be 72. And then in here you would do 2 times 18, 2 times 9, and 3 times 3. So remember that I make groups or pairs, and from the pairs I cross one out. Now, why am I grouping 2 in here and in here 3? Because the index is a 3 in here. No index means 2 in here, so that's why I make my groups of 2. And I'm going to get 1 from each group, so 2 times 2 times 3, and 2 times 2 is 4, times 3 is 12. So my answer is 12. So 12 times 12 is 144. Okay. I'm going to leave this on the side. Let's see if it fits so that you can have that little note in there. What about if my index is a 4 and inside of the symbol, the root symbol is 81? So in here we know that it's 9 times 9, 3 times 3, 3 times 3. How many do I need in the group? 4. And remember that from each group I only take 1 out, so the answer will be 3. It means that 3 multiplied times itself 4 times will give me 81. Okay? 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Okay, now I'm going to make it more interesting because I'm going to have the 4th square root of 81 to the 3rd power. So now we have this right here. All you have to do is first simplify this part, or you can do this part, but it's gonna make it a little bit more messier. So if you simplify this part, and especially that we have the answer already, that will be equals to 3. And we just bring this down to the third power, so that's gonna be 3 times 3 is 9, times 3 is 27. Okay? If you didn't really follow with this one, it's because I probably skipped the steps for the part that we already did. But let me do one where I won't skip those steps. Okay, so in here, the index is 6. Inside of the root symbol is 64. And then everything raised to the second power. So I'm just gonna do 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. How many do I need in one group? 6. 1, 2, 3, 4, 5, 6. So that's all of them basically. And remember that from each group I only need 1. So the answer will be 2, but that's only for this part right here. I still need to raise that to the second power. So I bring these 2 over here, and then 2 to the second power is 4. So that's all. Okay, with this you are able to do now 8.4. So have fun.